1. Start.
Hello students. Yesterday we have seen the session that about solutions, right? We have discussed what is a solute, what is a solvent, okay, and the different types of solutions depending upon the solute and the solvent. Also we have discussed about the methods of expressing the concentration. Okay, what is concentration? Concentration is nothing but it is the amount of solute present in the given volume of solution. Okay, now we would be seeing the continuation of the chapter, that is solubility. So what is solubility? Solubility is nothing but it is the maximum amount of a substance that can be dissolved in 100 grams of solvent at a given temperature. Okay, temperature plays a very important role in determining the solubility. For example, if you are taking about 100 grams of water and adding sodium chloride to it, initially what I will be doing is I will be adding about 10 grams of the salt. Okay, then I will stir it. So what happens? The salt will be dissolved in that. This process is called as dissolution. Okay, and as dissolution occurs, the concentration of the solution increases. Okay, then what happens is the solute particles present in the solution form, they will be colliding with the solute which is present in the solid state. Okay, immediately if we add, it will not dissolve, right? It takes some time to dissolve. So what happens in the meanwhile is the solute particles present in the solution will collide with they will be colliding with the solute particles present in the solid state. As a result, there will be the crystal formation of the solute which is present in the solution form. Okay, and this process is called as crystallization. Okay, I hope you have understood. What is crystallization? Nothing but the solute present in the solution form will collide with the solute present in the solid state in the solution, and it forms the crystals. That process is called as crystallization. Okay, so whenever we are dissolving a solute in the solvent or the solution, what happens is there is these two processes occurring simultaneously. What are the two processes occurring simultaneously? Dissolution and crystallization. Okay, and we will be keep on adding the solute. So what happens is at a particular stage, rate of dissolution is equal to the rate of crystallization. Okay, and that process, and at that stage the amount of solute present in the solution is called as solubility. Okay, for example, NaCl, right? NaCl at room temperature, if I am taking about 100 grams of water at room temperature, it can maximum dissolve about 35 grams of the salt. Okay, beyond that it cannot dissolve. That is what is called as solubility. Now let us see the factors affecting the solubility of a solid in a liquid. Okay, and the factors are nature of the solute and the solvent. Okay, so what do you mean by nature of the solute and solvent? Let us see. Nature in the sense, it is about the polar behavior. Okay, whether the substance is polar or non-polar, that we have to see. Okay, and this can be better said by telling that like dissolves like. Okay, so generally what happens is Polar substances are soluble in polar solvents, and non-polar substances are soluble in non-polar solvents. Okay, the best example we'll see over here is, if we take sodium chloride, it will dissolve in the water. Whereas if I take sodium chloride and add it in the kerosene or benzene, it does not dissolve. Then what is the reason? The reason is that sodium chloride is polar and water is polar. Okay, so when I add polar substance to the polar solvent, it will dissolve. Now, when I add sodium chloride to the benzene, it doesn't dissolve. Okay, whether if I add it to the benzene or to the anthracene, it will not dissolve. What is the reason? Because benzene and anthracene, these are non-polar solvents. Okay. Similarly, if we take carbon disulfide, that doesn't dissolve in the water. Reason? Carbon disulfide is non-polar, whereas water is polar. So this is about the nature of the solute and solvent. Okay. Next, coming to the size of the solute particles. Okay. This is our common observation, right? If you take solid salt crystals and powdered salt, which one will dissolve faster? Obviously the powdered salt. Okay. So lesser the size of the solute particles, greater or faster is the dissolution. Okay. Next, coming to the stirring effect. Stirring effect is nothing but if we stir, okay, if we stir the solute once it is added to the solvent, the dissolution will be occurring faster. This is our common observation, right? If you want to have milk, what do? We add sugar in that. We add either Bournvita or any powder, whichever we like, we add it and we stir it. Why do we stir? In order to make it dissolve faster. Okay. So greater the stirring, faster is the dissolution. Okay. Next, coming to the temperature. So again, here also we can take an example. If you take cold milk and hot milk, okay, add sugar to both of them. In which milk does the sugar dissolve faster? Obviously the hot milk. Okay, so that means when the temperature increases, dissolution increases. Okay, so these are the factors which affect the solubility of a solid in a liquid. Okay, let us quickly revise it. Those factors are nature of the solute and solvent, size of the solute particles, stirring effect, and the temperature. Next, we'll see the types of solutions based on solubility. Okay, so there are 3 types of solutions depending upon the solubility. Okay, those are unsaturated solution, saturated solution, and supersaturated solution. So what are these? Let us discuss. Okay, unsaturated solution, that means it contains lesser amount of solute than its solubility. Yeah, here we will take an example. The solubility of sodium chloride is about 35 grams at room temperature. That means what? 100 grams of water at room temperature can dissolve 35 grams of salt. Okay. Now what am I doing is, I am preparing a solution which contains only 20 grams of salt. Okay. So what do we understand from this? That means it can dissolve how much more? It can dissolve 15 more grams of salt, right? So the solution which contains lesser amount of solute than the solubility is called as an unsaturated solution. Okay? And an unsaturated solution can dissolve some more amount of solute. Okay. Next, we will be seeing the saturated solution. Okay, same example we'll take. So what am I doing is, I am preparing the salt solution by dissolving 35 grams of salt in 100 grams of water. Right? So what happens is, this water cannot dissolve some more amount of salt. Why? Because it has reached its saturation limit. That means it has obtained the equilibrium. In this case, the rate of dissolution is equal to the rate of crystallization. So what happens is, if I add some more amount of salt, okay, beyond solubility, it will not dissolve. Okay, at that stage or that kind of solution is called as a saturated solution. Okay. Next, coming to the supersaturated solution. Okay, a supersaturated solution is formed at higher temperature. Okay, now what am I doing is, to the salt solution, I'm taking the water and salt solution only I'm preparing. But in this case, what am I doing is, I am adding the salt more than 35 grams. Okay, that means actually the solubility of salt is 35 grams, but I am adding suppose 50 grams. So that 50 grams will not dissolve, right? So what I will do, I will heat it. So whenever I heat the solution, that means it is capable to dissolve some more amount of solute. Okay? And the solution which contains the solute more than its solubility is called as a supersaturated solution. Okay? Unstable solution. Okay, in the previous class we have discussed what is unstable solution. Unstable solution is that solution where the solute will separate out from the solution. That means whenever you are cooling down the supersaturated solution, the excess of solute will crystallize out. Okay, this is about supersaturated solution. So same example, I'll quote it with an example. I am preparing a supersaturated solution of salt by dissolving about 50 grams of salt. Okay? Actually, the solubility of salt is about 35 grams. So how much is the excess salt over here? 50 minus 35, that is 15 grams. So when this solution is cooled down, that means 15 grams of the salt will be forming the crystals. Okay, and remaining 35% will be present in the solution form itself. So this is about the types of solutions depending upon the solubility. Yeah, here you can see over here this figure. Okay, here unsaturated solution, it can dissolve, more solute dissolves. Whereas saturated solution, no more solute dissolves. Okay, whereas for a supersaturated solution, it becomes unstable. Okay, crystals are being formed. Okay. Next, types of solutions based upon the concentration. Okay, so what is concentration? It is nothing but the amount of solute present in the given volume of solution. Okay. If a solution contains more amount of solute, okay, it is said to be a concentrated solution. Similarly, if it contains lesser amount of solute, we call it as a dilute solution. And how can we come to know? Suppose if it is a colored solution, we can identify the solution based on its color. Okay. If it is a concentrated solution, its color would be intense. That means it would be darker in color. Whereas if it is a dilute solution, it would be lighter in color. Okay. See this diagram. So as the number of solute particles increase, the color will intensify. If the solute particles decrease, the color would be lighter. Now, we will be seeing about the solubility of a gas in a liquid. Okay? Many gases they dissolve in the water. One of the best example is the survival of the aquatic organisms. Okay? All the organisms, they require oxygen to survive. Okay? So how are these aquatic organisms getting oxygen? They take up the oxygen which is dissolved in the water. Okay? Oxygen, it dissolves to a smaller extent. And solubility of the gases in the liquids, it is affected by the pressure and temperature. As well, the nature of the gas also. Okay? If we see nitrogen, hydrogen, oxygen, these gases, they dissolve in the water to a lesser extent. Whereas the gases like carbon dioxide, ammonia, hydrogen chloride, okay, they dissolve to a larger extent. Okay, why these gases are dissolving to a larger extent? Because they react with the water. Okay, these gases, that is hydrogen, oxygen, they are not able to react with the water. Okay, so their solubility is less. And the concentration of oxygen in the water is about 5 ppm, 5 parts per million. Yesterday we have seen what is ppm, okay? Oxygen, the concentration of oxygen is 5 ppm. Okay, and this lesser concentration is sufficient enough to support the aquatic life. Okay, and another problem you might have seen, right? During the summer, what happens? The small ponds and lakes, they will be drying up, right? And the aquatic organisms, they will be dying. What is the reason? The reason is that during summer, the temperatures are high. So when the temperature is high, the amount of oxygen that is dissolved in the water becomes less. As the temperature increases, the gases will move up, right? So the concentration of oxygen in the water decreases. So when the concentration of oxygen decreases, that would affect the aquatic life. That is the reason why we see most of the aquatic organisms, they die in the small ponds and lakes. Okay? And let us see the another factor, that is pressure. A gas can be dissolved in the liquid to a larger extent when its pressure increases. Okay? Why? Let us see here. When the pressure increases, what happens is the number of gas molecules coming in contact with the solvent or the liquid increases. Okay, so the solubility of the gas increases. Okay, so this relation was given by the scientist Henry, and he has proposed a law. And what is that law? Let us see here. Henry's law states that the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the solution or the liquid. That means if I increase the pressure of the gas, the solubility of the gas increases. Okay? If the pressure decreases, solubility decreases. So this is about Henry's law. And this law plays very, very important role in our daily life. Okay? Let us see the applications of this. Yeah, this is the mathematical formula of Henry's law. The partial pressure of the gas is proportional to the mole fraction of the solution. Okay, mole fraction of the gas in the solution. So P is equal to KH. So what is P? P is nothing but the partial pressure. KH is called as Henry's law constant. And KH value is different for different gases. And X, it is the mole fraction of the gas. Okay. So yesterday we have already discussed how to calculate the mole fraction. Mole fraction is nothing but the number of moles of the gas divided by total number of moles of the gas into, if you multiply this mole fraction of the gas with the atmospheric pressure, we get the partial pressure of the gas. Yeah, see here. This picture relates to the application of pressure. How can we apply the pressure? By applying some weight by the help of the piston. Okay. When we are increasing the pressure by using the piston, okay, the number of gaseous molecules dissolving in the liquid or the solution increases. Okay. So this is the effect of pressure on the solubility of the gas. Let us see the applications of Henry's law. So, the first application is the production of carbonated beverages. Okay, yesterday we have seen carbonated beverages. What are those solutions? They are nothing but gas in liquid type of solutions. Okay, so these carbonated drinks, they are packed at high pressures of carbon dioxide. Okay, so in order to increase the solubility of carbon dioxide, the carbonated drinks are packed at high pressures. Okay, and next application is in the deep sea diving. Okay, deep sea divers. Okay, you might have seen people will be diving. They'll be having hobbies of diving, right? So while the person goes deep into the sea, what happens is the pressure increases as the depth of the sea increases. Okay, so when the pressure is increasing, the gases will dissolve in the blood. Okay, so the gases means what? Air is a mixture of gases. It has nitrogen, oxygen, and nitrogen is about 78%. So large amount of, there is a chance that large amount of nitrogen will dissolve in the blood. Okay. So when the person comes onto the surface of the sea. Once he comes out of the sea, what happens is there is large amount of nitrogen dissolved in the tissues, okay, in the blood. Okay, so what happens is because the pressure is more inside the blood, once the person comes out onto the surface, the surrounding area is having lesser amount of, the surrounding area is having the lesser pressure, and air flows from high pressure to low pressure. So what happens is when the diver comes onto the surface, nitrogen or the gases whichever are dissolved in his blood, they will be expelled out. So this results in the formation of bubbles in the blood. That is what is called as bends. This condition is very severe. If this condition goes severe, the person may die. So what happens is these divers, okay, they have to carry the respiration tank containing about 56% of nitrogen, helium and oxygen. Okay, so even they will be actually diluting the air with helium. So helium, the solubility of helium is somewhat lesser when compared to the nitrogen. So this is one of the application of Henry's law. Okay, next application is in the functioning of lungs. Okay, what are lungs? They are nothing but the respiratory organs. Okay, so what happens is lungs will be taking up the oxygen from the air. Okay, this oxygen binds with the blood. Okay, it actually binds to the hemoglobin present in the blood and forms oxyhemoglobin. This oxyhemoglobin, it reaches to the tissues, okay, where in the tissues the concentration of oxygen is less. Okay, because the concentration of oxygen is less in the tissues, this oxygen from oxyhemoglobin goes into the tissues, it diffuses into the tissues. Okay, this is how we are seeing the effect of pressure. Okay, the functioning of the lungs is because of pressure differences only. Okay, next application is for climbers or the people living at high altitudes. Okay, you might have seen people climbing. Okay, there will be few people have the passion to climb the mountain. Okay, so as the height increases, the density of air decreases. Okay, and as the density of air is decreasing, obviously the amount of oxygen decreases. Okay, so when the amount of oxygen decreases, what happens is it leads to anoxia. What is anoxia? Lesser amount of oxygen content is called as anoxia. So our tissues will be getting the deficiency of oxygen. So when the oxygen content decreases, it leads to and what happens is it doesn't make the person think properly. Okay, so in order to overcome that anoxia, the mountaineers, the mountain climbers, they have to carry the respiration tanks containing oxygen. Okay, these are the applications of Henry's law. Next, coming to the vapor pressure of liquid solutions. So what is vapor pressure? Let us see here. You know what are vapors? Vapors are nothing but when a liquid gets converted into the gaseous form, we call it as the vapor. Okay, water vapor, for example, water vapor will be saying. Okay, so liquids are of two types. What are those? Those are volatile liquids and non-volatile liquids. So what are volatile liquids? Let us see here. Volatile liquids, they are having low boiling point. Okay? And non-volatile liquids, they have high boiling point. So what is boiling? Boiling point? Boiling point is nothing but it is the temperature at which a liquid gets converted into the vapor. Okay, that is called as the boiling point. So what happens is, and another thing what we need to know is, the molecules of every substance, they will be having the attractive forces. Yes or no? Yes, they have the attractive forces. If a substance has to, if a liquid has to go into the vapor phase, means what? It should have lesser attractive forces. Okay? If the attractive forces between the molecules of the vapor are less, okay, then there is more chance for the liquid molecules to go into the vapor phase. Okay, so here we can also say that the volatile liquids, they will be having lesser interactive forces between the molecules, whereas non-volatile liquids, they have more attractive forces. Okay, so because the attractive forces are less, the molecules will go into the vapor phase easily. Okay, and for the liquids, in order to go into the vapor phase, okay, they have to overcome the attractive forces. So once they overcome the attractive forces, the liquid molecules will easily go into the vapor phase. So all these relations were said by another scientist that is called as Raoult. Okay, he has proposed a law known as Raoult's law. So what it is, let us see here. Vapor pressuring lower. He says about the lowering of the vapor pressure. So let us consider some amount of water or any volatile liquid. Okay, if we keep a volatile liquid and leave it in the surrounding nature, what happens? The liquid molecules, they will be colliding with each other. Okay, and few of the molecules will come onto the surface. The molecules whichever are having more energy, okay, they will overcome the attractive forces of the liquid and they go into the vapor phase. Okay, now what happens is, these vapors will be again interacting with the surface of the liquid. Okay, so when these vapor molecules are interacting with the surface of the liquid, they are exerting some pressure. Okay, vapor is nothing but gaseous molecules, and we know that gases, they exert the pressure. So the pressure exerted by the vapors on the surface of the liquid is called as vapor pressure. Okay, so now what happens is, I am preparing a solution. Okay, for example, I am taking water and acetone. Water is volatile and acetone is more volatile than water. Okay, now what happens? Now this, by mixing the water and acetone, a solution is being formed. Right, now the total vapor pressure of this solution is because of the vapor pressure of water as well as the vapor pressure of acetone. Okay, so here this law, it says that the total vapor pressure is nothing but the vapor pressures of both the components. Okay, how to calculate the vapor pressure? Nothing but it is the mole fraction of the pure substance and its pressure in the pure substance. Okay, that gives us the vapor pressure in the solution form. So see here, P total is nothing but it is the sum of the vapor pressures of both the components A and B, where P naught A and P naught B are the vapor pressures of two pure substances at a particular temperature. If A is totally involatile, that means it doesn't go into the vapor phase. That means P naught is 0. Okay, then the mixture of A and B will have a total vapor pressure than less than that of A. Okay, that's what. See here. If one of the component is non-volatile, so the vapor pressure of the solution is only because of the solvent. If the solute is volatile, the vapor pressure of the solution is because of both the solute and the solvent. That we need to know. And this is what is Raoult's law. Yeah, this figure says us about the vapors because of the pure solvent and the vapors of the solution. Solution means what? It has both solute and solvent. See, in this case, the pure solvent here, because it has only one kind of substance, pure solvent, it is only made up of solvent molecules. Here, it gives more number of vapors are there. Whereas in the solution, okay, the surface is occupied by both solute particles as well as solvent particles. So there is lesser chance for the solvent particles to go into the vapor phase. Okay, this is what happens when the solution is formed by using a non-volatile solute. Okay, so see here. For a solution containing a non-volatile solute, okay, that means what? We are preparing a solution by dissolving a non-volatile solute in the solvent, okay. So the decrease in the vapor pressure of the solvent depends upon the quantity of the non-volatile solute. That means, see, let me simplify this. I am taking water and I am adding the non-volatile solute. For example, I adding salt or urea, anything. Okay, these are non-volatile. So if I add lesser amount of solute, so the vapor pressure lowered will be lesser. If I am adding more amount of the solute to the solution, if I am preparing a much concentrated solution, the vapor pressure is much lowered. Okay. So this is what is Raoult's law. So Raoult's law can be stated that for any solution, the partial vapor pressure of each volatile component in the solution is directly proportional to its mole fraction. Okay. So lowering of vapor pressure is directly proportional to the mole fraction of the solute.